friends, and welcome to edupediaworld.com, your destination to online education. Friends, today we are going to start with the third topic of the language of chemistry, that is chemical equation. So in this session, we'll be discussing what is chemical equation. We'll be learning balanced and unbalanced chemical equations. We'll also learn why and how to balance a chemical equation. We'll be discussing how to make the equation more informative and the limitations of chemical equation. So let's start the session one by one with these subtopics with what is chemical equation. So friend, what do you understand by chemical equation? If I define, I'll say chemical equation represents a chemical reaction with the help of symbols and formulas. Therefore, I can write like this: symbols and formulas creates chemical equation. Now if I define it properly, I can say that the method of representing a chemical reaction with the help of symbols and formulas of substances involved in it is known as a chemical equation. For example, I take zinc metal which is reacting with dilute sulfuric acid to form zinc sulfate and hydrogen. Here you see the substance which combines and reacts are known as reactants. Here zinc and sulfuric acids are reactant, and zinc sulfate and hydrogen which are produced in this reaction called the products. The arrow sign you can see here pointing towards the right side is put between the reactant and product. This arrow actually indicates that the substance written on the left side are combining to give the substance written on the right side in the equation. So now it should be clear that a chemical equation is a shorthand method to represent a chemical reaction. So now to change this chemical reaction into chemical equation, what should we do? Let's find out. As now we know that the symbol of zinc is Zn, formula of sulfuric acid is S2SO4, formula of zinc sulfate is ZnSO4, and hydrogen is H2. So if I convert that reaction into the symbols and formulas, I'll get Zn plus H2SO4 giving ZnSO4 plus H2. So this is a chemical equation of a chemical reaction using symbols and formulas. Friends, there are many kinds of chemical reaction which may involve one reactant and two more products, two reactants and one products, two reactants with equal number of products, and two reactants which gives out three or more products. Let's find out with the help of example and understand the kinds of reactions present in the chemical world. First, we'll take one reactant giving out two or more product. Let's take an example of calcium carbonate giving out calcium oxide and carbon dioxide. Now we write it in the chemical equation. I'll get CaCO3 giving out CaO plus CO2. Now let's come to the second, when there are two reactants giving out only one product. For example, we have H2 plus O2 giving out H2O, right? Now if we take the another reaction which may involve like giving two reactants which is giving out equal number of products, like we have zinc plus sulfuric acid giving out ZnSO4, that is zinc sulfate plus hydrogen. Now if we take the fourth condition, that if we have two reactants giving out three or more products, how will we write the chemical equation? Let's take an example of potassium dichromate, that is potassium dichromate reacts with hydrochloric acid giving out potassium chloride, chromium chloride giving out water and chlorine. So you have seen here we have many kinds of chemical reactions which we can write the chemical equation respectively. So friends, now let's see this image carefully and this one. Now you can differentiate which one is more balanced. Yes, this one is more if we compare from the first one. So if we understand in terms of chemistry, the language of chemistry, we'll understand like this: balanced and unbalanced chemical equations. What do you mean by balanced chemical equation? I'll define. The balanced chemical equation has an equal number of atoms of different elements in the reactant and the product. Or I can say that the balanced equation has an equal number of atoms of different elements on both sides. I take an example here, the same example of zinc and the sulfuric acid. Now count the numbers of atoms of all the elements in the reactant and product separately. After counting the numbers of atoms, we see that the reactant containing one zinc atom and the product also containing one zinc atom. We have hydrogen atom 2 on the both side. We have sulfur 1 on the both side. That is the sulfur atom on the both side. Finally, we have 4 number of oxygen atom on the reactant as well as on the product side. So if we see here that there is an equal number of atoms of different elements in the reactant and product, so this chemical equation is a balanced chemical equation. On the other hand, if we talk about the unbalanced chemical equation, which has an unequal number of atoms of one or more elements in the reactant and product, or on the other hand, we can also say that an unbalanced equation has an unequal number of atoms of one or more element on its two sides. This point we can be more clear from this following example. I have given very small example of water, the reaction where the hydrogen burns with oxygen to form water, that is H2 plus O2 gives H2O. So if we count the number of hydrogen atom and oxygen atom in the reactant as well as on the product side, we'll see that there are two numbers of hydrogen atom in the reactant as well as on the product side, but we have the number of oxygen atom in reactant is 2 and in product it's 1. So this is actually we call as unbalanced chemical equation. So friends, as we have seen that the unbalanced equation which contains two oxygen atom in the reactant but only one oxygen atom in the product side, as it appears that the one oxygen atom has been destroyed in this chemical reaction. Can it be possible that if we see the law of conservation of matter, which state that the matter is neither created nor be destroyed in the course of chemical reaction. Can it be possible that the one oxygen atom has been destroyed in the chemical reaction? No. This means that the total mass of all the reactant must be equal to the total mass of the product. In other words, we can say that the number of various types of atom in reactants must be equal to the number of same type of atoms in the product. So it is obvious that we have to balance the equation. That is, we call it balancing of equation, that is chemical equation. So here the concept is why we balance the equation. That is, why do we balance the chemical equation? Because according to law of conservation of matter, matter is neither created nor destroyed. So unequal number of atoms of the particular element on the both sides should be equal. That is, it cannot be unequal. Like I have just given one example of water. So therefore we have to balance the chemical equation. Now let's see how do we do it. How can we balance the equation and comply with the law of conservation of matter? So friends, here we have some basic steps through which we can actually balance the equation, or we can say balance any kind of chemical equation, where first says that we have to count the numbers of times, that is the frequency that the element occurs on the either side. That is, we have to count the numbers of atom of that particular element on the both side. Then the element with the least frequency of the occurrence is balanced first. Third, when two or more elements have the same frequency, then the metallic element is balanced first. And if possible, to make our chemical equation more informative, we can put some signs and some subscriptions into it. Let's find out with a small example to make you understand the balancing of chemical equation. I'll take a very small example which will help you to understand these steps. I'll take methane bonds in oxygen to form carbon dioxide and water. So what is the solution? Let's write down. Let's write the chemical reaction first. What is the chemical reaction? Methane plus oxygen giving out carbon dioxide plus water. Now let's write down the formula. That is, let's write down the chemical equation now. As we know, methane is CH4, oxygen is O2, carbon dioxide is CO2, and water is H2O. So this is the chemical equation. CH4 plus O2 gives out CO2 plus H2O. This is reactant and this is product, right? Now let's count the numbers of various atoms in reactant and product. Count the numbers of atom of particular elements in both sides. I write reactant here. I'll write product here. I write the elements here. That is number of carbon atom in the reactant is 1. Here it's 1. Number of hydrogen atom in this reaction, that is this chemical equation, we have 4, and here it's 2. Number of oxygen atom, we have 2 and 3. So you see, you have here different numbers of hydrogen atom on the both side and oxygen atom different on the both side. So what we have to do, the number of carbon atom is equal to on the both side. Yes, we don't have to do anything to it, but the number of hydrogen atom and an oxygen is unequal. So to have 4 hydrogen atom on right side, we multiply H2O by 2 and write 2H2O dash. So what we have to do, we have to multiply 2 with 2H2O, right? So now this equation will be, let's write like this. It will be now this. Alright. Now again let's count the number of atoms. I'll write reactant, here product, number of carbon atom, number of hydrogen atom, number of oxygen atom. So carbon is 1 and 1, hydrogen is now 4 and 4, oxygen is still unequal. So now what we have to do, to have 4 oxygen atom on the left side, we multiply O2 by 2 and write 2O2. Let's write down the final one. We write now CH4 2O2 CO2 plus 2H2O. Now again let's count the numbers of various atoms on the two sides once again. I write reactant, product, number of carbon atom, number of hydrogen atom, number of oxygen atom. So here we have 1 and 1. Now we have here 4 and 4. Now we have oxygen, this. So this chemical equation contains an equal number of various types of atom in the reactant and product. So now it's a balanced equation. So friends, from this final equation, let's write down. I write CH4 plus 2O2 giving out CO2 plus 2H2O. So now from this equation we can write more information by indicating the physical state of the reactant and product as well as the heat changes taking place in the reaction. So let's find out in the future slides how can we add more information and make our chemical equation more informative. We can change or we can make the equation more informative by physical state of reactant, that is we can add physical state of reactants and products. We can also indicate heat changes and also we can write conditions under which reactions is taking place. Now let's understand by examples how can we do this and make our chemical equation more informative, right? Chemical equation can be indicated by first physical states. We can write the physical state, that we can add the physical states of the reactant and product. We can also indicate the heat changes and we can make more informative by indicating the conditions under which the reaction takes place. Let's understand now one by one. We knew that there are 3 kinds of physical states: solid, liquid, and gas. The physical state of reactant and products can be shown by putting the above state symbols, like we can write small letters liquid, gas we can write. And yes, for the aqueous solutions, we can also write AQ. Now let's take an example. Like we have zinc plus H2SO4, zinc SO4, right? We know that this is a solid, this is a dilute sulfuric acid, which is a aqueous solution, and we know that this is a gas. This is also a aqueous solution. Now we can write this equation: zinc S plus H2SO4 with AQ, which is giving out ZnSO4 AQ plus H2G. Now this equation is more informative because it tells us the physical state of various substances involved in it. It tells us that zinc is in solid state, sulfuric acid is in the form of aqueous solution, zinc sulfate is also in aqueous solution, but hydrogen is in the gaseous state. An arrow pointing upwards is used to indicate that the gaseous product in the equation. When the zinc reacts with the dilute sulfuric acid, zinc sulfate and hydrogen gas are formed. The formation of hydrogen gas can be indicated by putting an arrow pointing upwards with its formula. Like if we don't want to write the G, we can also write this arrow with H2. Or an arrow pointing downwards is used to indicate that the insoluble product or precipitate in an equation. Let's take an example of downwards. I'm taking here in calcium hydroxide, that is a lime water. This is a aqueous solution. Plus carbon dioxide gas is passed in the lime water, which is giving out CaCO3, that is a calcium carbonate. Plus water, which is in liquid form. So this is actually a white precipitate which is formed. So we can write this by downwards arrow. So when the calcium hydroxide solution, that is a lime water, reacts with carbon dioxide gas, a white precipitate of calcium carbonate is formed. The formation of calcium carbonate precipitate can be indicated by putting an arrow pointing downwards with its formula, right? So from the discussion, we conclude that the arrow pointing downwards, when put with the formula of the product in an equation, indicates that the product is being formed as a precipitate, that is an insoluble substance in the reaction. As we have taken this example, where the calcium carbonate is being formed as a precipitate in the reaction, and if we take the upward arrow, will indicate that the product is in the gaseous state, that is in the insoluble state. Point 2 states that we can also indicate the heat changes in the equation. We know that we have two kinds of reactions. That is, we have two types of reaction on the basis of heat change. That is exothermic reaction and endothermic reaction, right? So those reaction in which heat is evolved is known as exothermic. That is when heat is taken out is called exothermic. For example, when carbon burns in oxygen to form carbon dioxide, that is when C plus O2 we gives plus heat. So To indicate the exothermic, we can write like this. That is, we can add heat to the product side. And if the reaction is, this is exothermic, and if the reaction is endothermic, for example, when nitrogen and oxygen are heated to a very high temperature, they combine to form nitric oxide, where the lots of heat is absorbed in this reaction. So we can write here that N2 plus O2 plus heat gives out to NO. This is a balanced equation. So we can write plus heat in the reactant side, right? Now, if you take the third condition, which is to indicate the conditions under which the reaction takes place, that is, we want to check the conditions that if heat is required for a reaction to take place, then the heat sign delta, that this kind of sign can be given at the arrow, that is on the arrow. Or if the reaction takes place in the presence of catalyst, then the symbol or the formula of catalyst is also written above or below the arrow sign in the equation. For example, that is, catalyst can also be written either here or here, that is either side of the arrow. For example, if I take the potassium chlorate, that is 2Kl KClO3, which is heated in the presence of heat with the magnesium oxide, which gives 2Kl KCl in the solid state, that is potassium chloride, plus gives out oxygen gas. So you can see that when potassium chlorate is heated in the presence of magnesium dioxide catalyst, it decomposes to form potassium chloride and oxygen gas is formed. So here you can see, if I want to write the conditions, I have written delta, that is in presence of heat, and in presence of catalyst, this is a catalyst. This is a heat I have represented here on the arrow, and the catalyst below the arrow. So this is the extra information which we can add to our chemical equation to make it more informative. So friends, we learned many things in this session. We learned what is chemical equation, how do we write the chemical equation with respect to any chemical reaction. We also discussed what is balanced and unbalanced equations. We learned how to write the balance equation and why should we write the balance equation. We also got the information how do we enhance the chemical equation to make it more informative, as the chemical equation itself convey many informations, like it tells about the actual results of the chemical change. It also tells which substance takes part in the reaction and which substance are formed as a product in it. It also tells the number of molecules of each substance taking part. It also tells us about the chemical composition of the respective molecules. This also tells about the molecular mass. That is, we can calculate the molecular mass of both the sides of the compounds. And it also proves the law of conservation of mass. That is, the total number of substance on the two sides of the equation is same. But simultaneously, there are certain limitations of chemical equation. Let's see. As it does not mention the state of the substance, that is, it does not tell us whether the substance is solid, liquid or gas or in vapor state. We have to write it L, G VAP respectively. The chemical equation does not gives any information regarding the speed of the reaction, that is the rate of reaction. It also does not tells about whether the reaction is a complete reaction, and it does not gives the concentration of the substance, that is it does not tell about any information regarding the concentration of the substance, as it also fails to give the condition of the temperature, pressure or catalyst, etc. It also fails to give any idea about the color change which happens in the any particular chemical reaction. It also does not give any indication regarding the production or absorption of heat. That is, it does not give any information regarding if the chemical reaction is exothermic reaction or endothermic reaction. It also does not give any information if the reaction is reversible or irreversible. So friends, with all the pros and cons, I end up with this session with a small activity for you where I have given only two questions. In first, you have the balance to balance the equations, and in second, I have given you the chemical reaction. You have to just convert it into the chemical equation. So friends, in the next session, we'll meet with the radicals. Thank you for watching Edupedia World. Thank you.